We humans have been fascinated by our surroundings since the beginning. It's in our nature to probe and examine our environment, but like many things, if we are ever to fully comprehend the universe, we have to understand even its smallest parts. We know that everything is made up of molecules, and that molecules are made up of atoms, which are made up of protons, neutrons, and electrons, but our basic understanding of the universe starts to break down quickly at the next step: elementary particles. And that's kind of an issue, because if we are to ever fully comprehend the universe, we need to understand these particles. What we need is one unifying theory that accurately describes every physical aspect, including the smallest particle. This hypothetical idea is commonly known as the theory of everything. Currently, scientists rely on two theoretical frameworks on which all modern physics is based off of: general relativity, which we use on things with large scale and mass, like planets, and quantum mechanics, which we use to describe smaller things like molecules and atoms. Both of these theories work well for their given field, but fall apart when switched, or used when it comes to things like the nature of dark matter and space-time singularities. So scientists, particularly physicists, began looking for this theory of everything starting in the 1900s. And currently there are a few contenders, the most popular and infamous being string theory. The mathematics that build string theory are some of the more elegant equations of our time. As mentioned before, we know everything is made up of these mysterious elementary particles that we can't understand very well. They are so tiny, making them impossible to see clearly, though not being able to see something never stopped us from theorizing about it before. According to string theory, every particle in the universe that scientists previously studied consists of various combinations of vibrating strings. Like a stringed instrument that produces different notes, string particles create different forces of nature from their interacting vibrations, whether it be electromagnetism or nuclear forces. Even gravity, which has a difficult time fitting in with most theories, like the Standard Model, works perfectly with string. Leading string theory scientists such as Michio Kaku use string theory where other theories break down, such as the Big Bang. And if string theory is true, multiple universes could exist. However, much like other theories dealing with elementary particles, it comes with some issues. For instance, if string theory is to work, much of the math requires at least 10 to 11 spatial dimensions, and currently our universe is only considered to contain 3. So far, no one has successfully narrowed down string theory's dimensions. However, it is important to note that string theory is still a work in progress. And even if it currently hasn't worked, it is still incredibly useful. By studying it and its mathematics, we could find that long sought after unifying theory of everything. String theory has been the closest we've gotten to a unifying theory, and knowing humans, we will always be looking for the answer until we find one. Or we die trying. Who knows, maybe you'll be the one to solve the mystery.